So that was Mr. Kaplan on the front side. Here is the back side. We'll just continue the rules. Again, z to the -4 to the 6th. I'll take a slightly different approach just so that you can see something else. This would be 1 over z to the 4th raised to the 6th power. Right, so I just took the negative and put it in the denominator, converted to a positive. And now I can rewrite this as Mr. Kaplan explained by just distributing the negative, or sorry, the exponent to each of the terms. Now you have to be careful that you can't just always distribute the exponent to, if you had 1 plus x here, you don't just distribute the 6 to the x and the 1. It just is only when you have a single term here, a monomial, that you can do that. So this becomes 1 to the 6th over z to the 4th to the 6th. And 1 to the 6th is just 1. And z to the 4th, all raised to the 6th, is z to the 24th. So that is your solution. This next one's interesting. When you have common bases, which are the y's, you add the exponents, and -4 plus 4 is 0. So I have x to the 6th, y to the 0, but we know y to the 0 is just 1. So 1 times x to the 6th is just x to the 6th. On the next one, again, I'm going to simplify here first for x minus 2 and x to the 7th. Common base, add the exponents. So you have x to the 5th plus 5x to the 9th. Now a lot of people will be tempted at this point to do something from here. Oh, it's a common base, I have to add the exponents, or it must be the product of the exponents, I multiply them. Remember, that's only over multiplication. When you're adding, you need to have the same base and the same exponents to add them. So at this point you can't do anything further because x to the 9th cannot be added to x to the 5th. It can be multiplied, but that's not what we're asked to do here. Likewise, let's look at this one. So this is 4x to the -2 cubed. So one thing I could do is distribute the cube. So this would be 4 cubed x to the -6 minus 6 over x to the 6th. Now in this next step, what most students do is when they move the x to the 6th, to the -6 to the denominator, they bring the 4 cubed with it. Well, this is not 4 to the -3. This is just 4 cubed, so it stays on top. While the x to the 6th goes to the bottom and becomes positive. Minus 6x to the 6th. Now 4 cubed is the same as 64. So this is the same as 64 over x to the 6th minus 6 over x to the 6th. And because I have a common denominator, I can subtract the numerators, leaving me 58 over x to the 6th. Okay, so a combination of ideas here, right? Make sure you don't bring anything that isn't raised to a negative power down to the denominator or up to the numerator if it starts down below. And make sure you need a common denominator to add or subtract. And this last problem, automatically on the outside I see something to the 0, which means everything that is being raised to the 0 is just 1. So I can rewrite this. 5 to the 0, 5 to the -6, all to the -3rd over 2x to the -4th minus 1. So now, again, a few things you can do in here. Notice I have a common base here, base 5, so I can add my exponents. So I have 5 to the -6th over 2x to the -4th, all raised to the -3rd minus 1. Now, this -3rd, I can distribute, but I need to make sure I take it to all pieces. 2 is a coefficient of x to the -4th, so that needs to be raised to the -3rd. But 5 is the base itself, so I don't raise 5 to the -3rd and -6 to the -3rd. I just raised the negative 6 because that is the common base. So we get 5. Negative 3 times negative 6 is 18 over 2 to the negative 3 x to the negative 4 times negative 3 is positive 12 minus 1. And now I just have one more piece to deal with, which is this 2 to the negative 3rd. Bring it to the numerator. 2 to the 3rd, 5 to the 18th, all over x to the 12th minus 1. And you can leave it just like that. No need to expand this into some large number. So hopefully between Mr. Kaplan and I, you have a flavor now of the variety of things that you could encounter with addition, subtraction, multiplication, division, and raising to exponents with 0 and with negative exponents.